Today we're going to continue with section 10.2, which is more with the hyperbola. Today we're going to graph when the hyperbola is not centered at the origin, and we're going to write some equations in standard form. So a quick reminder of yesterday, here were our standard form equations, but now we, like I said, are going to be really focusing on when our center is not at 0, 0. So I have a couple of pictures here where notice that we've got the graph shifted on the left, it's over in the first quadrant for our center. I mean, same thing with the second picture, okay? But this is where it's going to be super important that we still remember that our center is HK and we take opposite signs. So especially with the information over on the right-hand side, it's not going to be the first number in the parentheses that helps identify the center. We have to always go to the parenthesis that contains the X term to help us identify our center. And then we're still using the information that c squared equals a squared plus b squared to help us find the foci. Let's take a look at this example. It's already in standard form for us. Remember, based off of our information from yesterday, a squared is always going to be that first denominator, and b squared is always going to be the second. So when we take the square root of both of those, notice that we are dealing with our a term as 4 and our b term as 5. Okay, so we can find our c value by taking 16 plus 25, because remember that equals c squared. So when I add those together, I'm going to get 41, and so take the square root, and the square root of 41 is going to be our c value. Notice that above the a squared term, we see the letter y. So that's going to tell us that we are going to be opening up and down. The transverse axis is the y-axis. Now, to identify the center, we're looking at the numbers that are in the numerator with the x and the y. But remember, h goes first. And I don't know why my pen's not writing. All right, sorry. My h value is going to go first. Notice that that is the value in the parentheses with the x, and we always change the sign. So -1 is going to start our center. Go over to the y value, change the sign, and 2 would be the second half of that. All right, so when we are identifying our vertices, because we know that the y is the transverse axis, that means that my vertices are going to stay at -1 to begin each one of those. I'm moving up and down from the center. So I'm going to have to take my number that's in the second part of the center, and I go over to my a value, and I'm going to add 4 onto 2, and I'm going to subtract 4 onto 2. So that's why my two numbers, or my two ordered pairs, would be -1, 6 and -1, -2. Same idea with the foci. I keep the first number the same because I know that my foci is going to have to move up and down along the lines as the transverse axis. So that means that I'm going to take 2, and I'm going to be adding and subtracting the square root of 41 from it. Now, because that's a radical, I'm okay with you leaving your answer as far as identifying your foci ordered pair as that. All right, so I'm going to start plotting some of these points. -1, 2 is going to land me over here in the second quadrant. I know that I want to have -1, 6 be a point, as well as -1, -2. Now remember, that was the a value. The b value then is the conjugate axis, or helping me get that, and I'm going to be adding and subtracting 5 onto the first part of my ordered pair. So -1, so from the center, basically, I'm moving 5 to the right, 1, 2, 3, 4, 5, so that takes me to the ordered pair of 4, 2. And then from the center, move 1, 2, 3, 4, 5 to the left, and that takes me to -6, 2. And so then those points help create the box that begins the shape of my hyperbola. So the foci, I'm going to take 2. I'm going to add the square root of 41 onto it. and that is approximately, so the first number for my foci is approximately 8.4. So I know that one ordered pair for the foci is at -1 and then up here at 8.4. But then now I have to take 2 and I have to subtract the square root of 41, and that's approximately -4.4. So from -1, I'm going down to -4.4. Once again, the foci are outside of the box. To find your asymptote equations, it's going to be whatever is in the parentheses for the y, okay? So we'll do y minus 2 equals, I'm going to have two asymptotes, both positive and negative. And so if you're trying to remember, okay, what goes on top, A or B, go to your picture, go to the center. Remember, slope is rise over run. So from the center to like this corner right here, I had to go up 4 and then over 5. So that tells us that our slope was 4 over 5. And then that gets multiplied by whatever was in the parentheses with the x, which was x plus 1. And there are my two equations for my asymptotes. And so notice that if I think about my slope of 4 over 5, I can then from that corner go up 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, and continue extending that. And then from the center, I know I'm at the corner. And then I go down 1, 2, 3, 4 over 1, 2, 3, 4, 5 to continue that asymptote. And then I can do the same thing with the other corners. I know that I need to go from the center to the corner down here on the right, and then go down 1, 2, 3, 4, and then over 5, 1, 2, 3, 4, 5 to continue connecting to form that asymptote. Connect to the corner from the center here. From that corner, 1, 2, 3, 4 up, 1, 2, 3, 4, 5 to the left to finish that asymptote. And then remember, we're opening up and down. I want to go from the vertice, which is at -1, 6, and start getting closer and closer and closer to those asymptotes that I just drew. And then from -1, -2, from that vertice, I'm going to be drawing and getting closer and closer and closer to my asymptotes. And there's my graph. All right, what if we had a problem where it was not in standard form? Our first step is I got to figure out what the standard form equation is. And so just like what we did with an ellipse and even with circles, we're going to have to complete the square. So I'm going to have my x terms together. I'm going to have my y terms together. And then I got to make sure that it equals the number. So I'm going to add 153 over to the other side. Okay, in order to complete the square of the first two terms with x, I never want a lead coefficient in front of the squared term. So that means because there's a 4 out in front, I'm going to factor out that 4. So that leaves us then with x squared minus 6x in the parentheses, and then I'm going to leave a spot for me to actually complete the square. When I'm looking at the y terms, this is where you have to really be careful. It's not just a 9 that's in front of the y squared, it's a -9. So I'm factoring out a -9, which then leaves us with the y squared plus 10y. And then I'm going to leave a spot for me to complete the square. And so because I'm completing the square not once, but twice, I need to make sure then that I'm adding two numbers over on the right. So I'm looking at the number of -6. I'm going to divide it by 2, and I'm going to square it. Well, -6 divided by 2 is -3. -3 squared gives me 9. But remember, because we took out that GCF, it was not really just a 9 that got added over on the left. It was a 36 because I had to multiply and distribute that 4 back. So that's why I had to add 36 over on the right. Then I take my 10. I'm going to divide it by 2, and I'm going to square it. Well, 10 divided by 2 is 5. 5 squared is 25. But remember, it's -9 times 25 that I really added on the left. So when I multiply -9 and 25, I get to 25, and so that's the number that gets added on the right. So I still have that 4, but now I can factor what multiplied to 9 but adds to -6. Well, that turns into this x minus 3 quantity squared. Remember, that -3 before we squared it is what goes in the parentheses. All right, then I'm going to have a positive sign, and then I'll have my -9. Okay, I just like to keep the negative in front of the parentheses here so then we don't lose negatives. All right, now I'm going to start factoring. What multiplies to 25, it adds to 10. Well, that would be 5 and 5. So notice how that positive 5 goes there. That's quantity squared. If I add those three numbers over on the right, I'm going to get -36. So we're still not done yet. I got to make it equal 1. So that means I have to divide everything in this equation by a -36. So when I divide, notice that I'll have an x minus 3 quantity squared on the top, and then I'll have a -9 on the bottom. Plus, when I reduce a negative divided by a negative, notice that will leave me with a positive number or term on the top, and then I'm going to have a positive number on the bottom, and now that equals 1. Okay, even though there is an addition sign here, it is a hyperbola because one of my terms is negative. So really then I would rewrite this as the fact that the y terms first because it was positive. Oops, that's -3. And then since the 9 was negative, I could really subtract that now x term. And so there would be my hyperbola in standard form. All right, so once we have that, that's what I'm asking for us to graph. So remember, our a squared term is always first, b squared is always second. So take the square root, we get 2, and we get 3. C squared is us adding 9 and 4 and taking the square root. So that would be the square root of 13. Because our y value is on the top of the a squared term, once again, we are going to be dealing with our transverse axis on the y-axis. So we know our graph's opening up and down. Our center, once again, be careful. It's always our h, comma, k. H deals with the x term. I'm going to change the sign, so 3 goes first. Then you go over to the number with the y, change the sign, and -5 goes second. So there's my center. Our vertices then, because I know that I want to be moving up and down, the first number as my center is going to stay as it is for my vertices. I'm taking -5 and I'm adding on my a value, and I'm taking my -5 and I am subtracting my a value. So that gives us the ordered pair of 3, -3 and 3, -7 as our vertices. So then our foci, keep that first number for my center because I know I'm moving up and down. -5, now I want to add and subtract the square root of 13 to get those foci. So I'm going to start plotting my points. 3, -5 falls down here. I know that I want 3, -3, and I want 3, -7. To help me finish my box, remember from the center, look at your b value. I'm going to add 3 to move over to the right, and from the center, subtract 3 to move that over to the left, and then that forms the box. So we have a pretty small box this time. Remember, the foci are going to be outside of the box. So if I'm looking at the numbers, -5 plus the square root of 13, well, that's approximately -1.4. So 3, -1.4 would be over here. And then also, if I have -5 and I subtract the square root of 13, I get approximately -8.6. So at 3, I'm going down to -8.6, another point that's outside of the box, which is what I want. Okay, remember our equation for our asymptotes. We look at the y values, what's in my parentheses, that's what I'm going to have. So I'm going to have y plus 5. That equals positive and negative. If it helps to look at your picture, remember from the center, I want to go to each corner of my box. So notice from the center, I have to go up 2 and then over 3 to the right. So 2 over 3 is my slope because I can't reduce that down any further. And that gets multiplied by whatever was in the parentheses dealing with our x. So x minus 3. All right, so if I start drawing my asymptotes, I'm up 2 over 3 from the center, up 2 over 3, up 2 over 3. So it's going to look like that. So then I can go down 2, 3 to the left, down 2, 3 to the left, down 2, 3 to the left, and I can continue building on to that asymptote. And then same idea. I can go up 2, but then 3 to the left, up 2, 3 to the left, and so on and so forth. There's enough points there, I feel, to help me create that part of the asymptote. I know it goes down to the corner here, where then I go down 2, 3 to the right, down 2, 3 to the right to finish that. And then from the vertice, I know that I'm going to be getting closer and closer and closer to the asymptotes on moving up and down. And there would be my graph. Let's look at a couple of problems where we have to create our equation. So we want to find the standard form equation of a hyperbola. We're given the foci to be negative 4, 0, and 4, 0, and the vertices to be negative 3, 0, and 3, 0. So it doesn't matter which one of those sets of points we pick, but we want to figure out what the center is. So to find the center, we want to take the midpoint. So say I use the foci points. I'm averaging those together. So I'm going to add the x values, divide it by 2. Add the y values, divide it by 2. Hopefully we're okay with seeing negative 4 plus 4 is 0. 0 divided by 2 is 0. 0 plus 0 is 0. 0 divided by 2 is 0. So our center is at 0, 0. And so because we always want our... if they're telling us that our foci is negative 4, 0, 4, 0, remember foci deals with our c value. So hopefully we're okay with noticing from the center, we're moving 4 to the left and to the right. And so that would be our c. I know that my vertice is going to be dealing with the a value. So from the center, notice if my vertices are negative 3, 0, and 3, 0, I'm moving left and right 3. And so now that I have that information, I can find b, because remember, c squared equals a squared plus b squared. And so 4 squared would be 16. 3 squared is 9. That needs to now, I need to start solving for b. So I'm going to subtract 9 from both sides. And so now I'm going to have 7 equals b squared. And so notice that that means that my b value is the square root of 7. So because my center is 0, 0, I know that I am going to not have numbers with my x and my y terms. Because we were moving left and right for the foci and for the vertices, I hope we're okay with the fact that our transverse axis is going to have to be dealing with then the x. We're moving left and right. So I'm going to put x squared first then, because my a squared term is going to go first, and that dealt with my vertices. So square 3, and that's 9. There's the first half of that equation. There is no number with the y because it was the ordered pair 0, 0 for the center. So we'll just have y squared. And then once again, b squared, which was 7, is going to help us finish that equation. So here is our answer in standard form. If we want to find the standard form equation of the hyperbola, we are given the endpoints of the transverse axis to be negative 4, 4, and the asymptote is 2, 1. All right, so when we're given our ordered pair of the endpoints of the transverse, we're basically given then the vertices. And so we know once again that our vertices deal with the a value. So if we know what our center is, we can then find our a value. Hopefully we're aware, just like in our last example, that if we are dealing with negative 4, 0, and 4, 0, if I was to average those, our center is at 0, 0. So that means we were moving left and right 4. When we're given the asymptote, notice that because then our transverse axis is really the x-axis because, once again, our vertices move left and right. We are thinking about the fact that our slope is going to be b over a. And so because I already know what a is, I know that a is 4. My goal is to figure out, okay, well, what divided by 4 then really turns into 2 over 1. All right, so if you want, use this right here, use this proportion and cross multiply. If we cross multiply, 1 times b is b, 2 times 4 is 8, so b has to equal 8. And now that I have that, that's really all I need because I don't need my c value in order to just write the standard form equation. So while you could definitely find c, it didn't really matter in this problem. All right, once again, our transverse is the x-axis. Our center was at 0, 0 if we were to have averaged those vertice points. And so that's why x squared is going to go first. Y squared will go second. A is 4, so square that, and we get 16 underneath the x squared term. B is 8, so square that, and 64 is underneath the y squared. And then, of course, this has to equal 1 to be in standard form equation, and there is our answer. Okay, the last problem, we want to find the standard form equation of the hyperbola. The center is at 4, -2. Our focus is at 7, -2, and our vertex, one of the vertices, is at 6, -2. All right, so if I'm given the center and I'm given a focus point, notice how the number that is not changing is the y. So what that means is that since the x values are changing, our movement is left and right. And so moving left and right deals with the x values. So the x-axis is going to be our transverse axis. All right, so that means that when we're stating our standard form equation, we're going to have to put x first, and we're going to have to put y second. Now remember, whatever our center is, we're going to change the sign to fit in the parentheses of our equation. Since 4 is positive, I want to say x minus 4 quantity squared. Since the 2 is negative, it's y plus 2 quantity squared. All right, so we have the numerators. We just have to find the denominators. Notice that our distance from the center to the focus, so from 4 to 7, well, that's a length of 3. To go from 4 to 7 is 3. And remember, a focus point is going to be our c value. So we just found c to be 3. To go from our center to our vertex, notice that we're going from 4 to 6. Well, 4 to 6 is a length of 2. That's our a value. So I know a is 2, so square that, and 4 has to go underneath the first term. Our goal is just to find b. So remember, c squared equals a squared plus b squared. C squared would be 9. A squared we know is 4. So notice that, subtract 4, b squared then, which is what I want in my denominator, is 5. And there is my equation. So I would suggest that you pause this right now and at least try to make sure that you can complete the square correctly to get your equation of this hyperbola. Okay, so hopefully you were able to get that equation of y minus 1 quantity squared over 4 minus x minus 3 quantity squared over 9 equals 1. And then from there, you can go ahead and graph. So that's us with parabolas that were not centered at the origin and writing equations in standard form.